thank you for attending my talk. And yeah, I'm very happy to be back at KanDDDinsky again after some years. And my name is Carola. I'm from Hamburg. So normally it's just 1 hour 50 away from Berlin. At those times now it takes 2 hours 30 or something because they are working on the railways. But anyway, I'm here enjoying Berlin. And in Hamburg is my hometown, my base town, where I'm sitting with my company, WPS Workplace Solution. You have seen our booth outside probably as well. And I've started my career in 1995 in computer area. I started to program. I did a lot of programming in C++ at the beginning, and then in Java a lot. And I did project management, and I was software architect a lot. And this was sort of my hard topic, the topic that was most important for me. And in 2004, I had the chance to run into the book of Eric Evans, and I read the domain-driven design book and fell directly in love with it, with the idea that we could design our software following the domain. So since then, in our company, we are programming with domain-driven design. And when I speak about we started 2000 with 12 people, and now we are 170 people and doing a lot of great projects. So whenever you drive with your car on the German Autobahn, and there is some work, some construction work, then this construction work was planned and organized with the software of my company following domain-driven design. No? So you can be sure it works, you know. So the only problem is that you don't want any construction works in front of you, but I can help that. This is necessary. Well, we started to do domain-driven design in our projects, and then step by step people started to ask us, and we started to help them with their domain-driven design problems or with their problems in general with their software. And we started to especially help people that had legacy software to transform this software in modern times, to deal with that thing, you know. I worked a lot on legacy systems, and we combined legacy systems, legacy software with domain-driven design, and ended up with something that Henning has presented last year, I think, as well. We called it domain-driven transformation. So we transform legacy software with domain-driven design. This is what we do. And by doing this over the years, we got the impression that with some domains and their software, one or several, it was much easier to transform that thing than with other domains and the software in those domains. And this is the heart of my talk. I will take you to domain-driven transformation so that you understand, and then I will show you what we found. And I'm presenting this here without any real statistic evidence today, you know, it's just what we saw in our projects with our clients, and I'm really keen to know what you think about it. So please give me feedback after that talk about domain patterns. Well, what is happening normally, you know? Normally someone calls me, oh, Carola, well, they write emails also okay, but Carola, can you help us? We have a problem with our software. And then I know already, blah, 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 too old, legacy, can't change anything anymore. And I say, yes, 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 we can help you. What do you have? And the other day, someone said, well, we have 3 million lines of Java code. I say, well, it's big, but I have seen bigger ones. You will see this in the talk as well. It's okay, yeah, and what's your problem? Well, we can't change it anymore. We can't add new features. It's really horrible. Okay, I say, how many people are working on that thing, you know? Well, 30 people. 30 people, and they are just doing maintenance? They can't? Yes, yes, yes. That's the problem. oh, I say, well, you really have a problem, you know? You should have like 12 people doing maintenance, and the rest, the 18, no, the rest should have time to do some enhancements. And then we go there and we look into the software and blah, blah, blah. And normally and often it looks like this, you know? Like, no. And it looks like this. Well, if you look closely, you see the first thing was a very good idea, a very, very good idea. A small castle in a river, you know, with another little one, you see that one over there, so very protected, a very good idea to build a castle at that spot. So the software was brilliant. The first version was really brilliant. And everybody said, oh, this is so brilliant. Can't you put this feature in there, and that one, and that one, and that, and then floof, you know? And then this is what happens, you know? And you all know that probably, you know? You all have to deal with things like that. My young colleagues that arrive in the company after university time, you know, I tell them these days, listen, you will be lucky if one time in 10 years, you will start a system from scratch. You know, the rest of your time, you will have to deal with that, you know. 10 years ago, I told them every 5 years, you know. It's getting more difficult, yeah. But you all know that. We are all building things like that. And then we look inside, we often find things like this. This is a tool-generated graph from a real system. Now the structure was analyzed and parsed, and every square is a class. No? And all the arrows are connections. So one class is calling another class. You can't see it exactly, but all those little lines are arrows in both directions. So they know each other. And the colors indicate that actually we discussed with the architects the architecture, and we said, okay, this package should be in the green component, and this package should be in the blue one, and so on. So we organized the whole system in different colors for all the modules, and you see the colors all over the place. And this is a class cycle, you know? They all need each other. You can't pull any of them out. And you can imagine what this means, can't you? If you want to change something, you have to take the whole thing into account. You know, if you write a test, you have to mark the whole thing. Yeah? It's really horrible. And, well, 463 tangled classes is actually middle-sized, you know. I've seen things like that with 5,000 classes. And this is, you can't do anything with them anymore. So if we find that, we know, okay, yeah, typical problem. And then we, well, what do you call that in domain-driven design? You all know. This is a big ball of mud, obviously. And, well, we tell them, listen, you have a big ball of mud, and where you want to go is this. You know, you want to have different single modules that have clear colors and are separated from each other. And then we say, well, our transformation process works like this. You start with domain rediscovery. So we have to rediscover the domain. I will show you what this means. We will determining the target architecture, so we have to find out where to go, well, what's the goal. Then we have to compare what you have now with the goal, you know, very clear, and then we're gonna do the move. And I'm gonna show you these 4 steps with a very small example from Henning, who has programmed for a while in the leasing context. So people who want to lease a car, how does it work? And I will show you this first step to rediscover the domain with a domain story, which is one of the techniques from collaborative modeling. If you were here before, you saw event storming, of course, and domain storytelling is one of those techniques. And how does leasing works? This is a process that fits on one slide, okay? This is not how it really works yet, just but for the fun. You have a customer, you have a salesperson, and you have a risk manager. And the customer comes and tells the salesperson, I really want this this car, this special car. This is what I need. And the salesperson starts to calculate the installment for the contract, and the customer signs the contract, and then the salesperson passes the contract on to the risk manager so that he can check this contract, he checks the credit rate, he calculates the real sale price of the car, and then finally, if everything is fine, and we just go for everything is fine, you know, he will vote the contract and say, well, this is okay-ish, you can do that, salesperson, and then the salesperson gives the car to the customer. Very simple version of this process, of course. So this is the first thing that we do, and we do this with the domain experts in general and with developers as well. But we need the domain experts. And this is often a bit difficult, you know, because the domain experts, they say, oh, you already have a system, you know what it does, you know, just leave us alone. And I understand that, but my experience is that the developers, they know a lot about the software, but the real reason from the domain is a bit more far away in the head of the domain experts. So we try to convince them to give us 2 hours, you know, just 2 hours, just for the stupid people from outside. Just explain us. And if we get them into the room and do this, it works. You know it from event storming, you know as well, it works. You can do it, and the people will give you their 2 hours, and afterwards they are so happy that they can finally see how they work, you know? So this is another outcome for them. The second thing that we then do, I will shorten that a bit, is step number 2. We determining the target architecture. What do? We try to find subdomains in these processes. And here we just create 2 subdomains. So we say over there, this is the sales part of the process, and over here is the risk assessment. And then we talk to them later on or in the same session and do different domain stories, and we come to several of these subdomains: risk assess, management, sales. Maybe we find price calculation. They have to calculate the price. Probably risk reporting, you know, in insurance you always have to do a reporting about the risks. And probably payment is there too. So we will find some more subdomains in this area. And then, of course, you all know that. What do we do if we follow domain-driven design? We create a context map. I reduced it to 3 again here: sales, risk management, and payment. And we start to discuss with them the context mapping. How do they work together? So this is the target architecture. This is where I want to go from a domain perspective. And then we compare it with the actual system. Maybe it looks like that. And they put them onto each other, and well, the effect is often like this, you know. It doesn't fit. The software is cut into modules that are completely different than the context map that we encountered. And then the people start to ask us, well, how horrible is the problem, you know? Will it be easy to change that or not? And we discussed in our team, how could we answer that question? And we invented something that we call the Modularity Maturity Index. So we give them a grade from 0 to 10, where they are with their structure in the software. And I will show you like 21 systems. I will start there. If you're very bad, you're in between 0 and 4. If you're in the middle, mediocre, you're between 4 and 8. And if you're really good, so if it fits pretty well, you're between 8 and 10. Managers love that, of course. And then you have a possibility to tell your manager, look, we have 6.8. If you give us some money, we get up. No? I will show you some of them. 21 systems. I will explain to you what you see. You see bubbles in red, in yellow, and in green, and some are huge and some are small. The size is the size of the software. So on the left side up there, almost 15 million lines of Java code, a very good system. Because it's good, I can say its name. The Germans who are insured with the Techniker Krankenkasse, they can be happy because their system is in a really good shape. The red ones down there, I will not tell you any names. Do you understand? Yeah. From left to right is just the time, you know. We started with that red one, then we did the big green one, and so on. There is Java in there, there is C#, there is C++, there is PHP as well. And the big one up there, the best big one, the almost 10 million lines of code, it's a C# system. It's a system that is created in Romania. So if there are any people from Romania, very, very cool system. I've never seen anything brilliant like that before. It's a system where some customers sent us to look at because they had, does this work? Yeah, they had this system down here. And they were really suffering, you know. The people in the development team got up at night to restart the server, which should normally not be the case, you know. And they had programs that ran in the morning to repair data failures in the database that had been created at night with a night shift program. So, I mean, really, it was horrible. And the most horrible thing about that system was that it was originally programmed in Smalltalk. And you could still see the original wonderful architecture in this system, but it had been translated to Java with some program and was enhanced and enhanced, and nobody remembered the original idea. So it was really frustrating. And they said, well, there is another system that maybe we could buy. It's doing the same thing. And I said, yes, well, why not? But maybe you sent us there before, so we look inside and you don't fall into something that is even worse. And it was this one up there, you know, the big one up there. So we told them, well, if it's doing the same thing from a modularity point of view, I would do it, you know, I would change. Okay, but this is normally not what I tell people to do with their legacy. Normally, I tell them to do something about the source code that is already there. You know, normally the people are in the yellow area or somewhere there. And how do we do this? How do we come to this measurement to modularity maturity index? Well, we are doing sessions with the people. We are looking with tools on their software, and there is an algorithm with over 21 measurements that we calculate all together to come to this final number. And this is published, so you can look into those 2 books and into my other books as well. You can find the algorithm, so you can do it yourself. You know, you don't need to rely on us. But of course, we come and do it if you want. So, well, what we see is that typically the systems down there, they are a big ball of mud. The systems in the middle, like until 2 or 3, no, maybe now 4 years ago, when people called me and I asked them, what architecture do you have? I mean, of course, nobody said a big ball of mud. But they always said, we have layers. This was the answer. And this is what we find a lot, technical layering, you know. And I'm sorry, but it's better than nothing, you know. I mean, everybody is saying bad things about technical layering, but I started my career in the 1990s, and at that time, there was even no layering, you know? even no layering. In the front end programming, there were SQL statements. You know, this is where we come from, and we came there in 30 years. It's pretty good what we did in that time. So technical layering is better than nothing. Okay, but of course we want something else today. We want domain-driven modules. This is what we want. We want separated small bits and pieces. And everybody wants to come from down there up there. Of course, people want to be up there. And yeah, this is where we try to help them, and we try to help them to get to this state where we have separate modules with a layering inside, and we have just some coupling in between. So for a modularity maturity index of 10, you need a modular architecture with high cohesion and loose coupling. And for me, loose coupling is really important. And you should have a look that you don't just use your technology to do loose coupling, but I can send an event, you know, and then after a while you have hundreds of events flying around in your system. Don't do that. Look at it. Is this a good decoupling, what we are doing? No. Okay, but, you know, if you have a big ball of mud, the path to go is quite long. And I try to explain it often like this. Well, you have bad modularity in your system, but this is not the whole problem. You all as well have bad design, and you're even bad at a lower level. You have low security and infrastructure, and you have so many bugs. This is why they have to stand up at night to restart the server and things like that. So when we have a big ball of mud in front of us, we don't start to tell them to cut the thing into modular pieces. This is impossible. So what we do at the beginning is that we tell them, start on the bottom, you know, do something for your system. Automate build and development. I don't know if you can imagine, but out there are still companies that don't have any automation for the build and for the development. It's done by hand still, you know. Update your frameworks and libraries. This is so horrible that what old libraries you find out there in the wild, it's unbelievable. People still doing Java 10 or whatever, I mean, unbelievable. Improve your error resilience, increase test coverage, do something to get the system in a changeable state. This is the first step, you know? And the good thing about it is when we suggest measurements like that, when we suggest that they do these little steps, you can quickly do that. It's much quicker than to change the whole architecture. And you can quickly tell your management, well, we achieved this, and we achieved this, and we achieved this, and the management is happy because you arrive at something. And then you can do the next step. You can do something about the bad design. You can enrich the domain modeling. You can start to use value objects. You can resolve cycles, dependencies, reduce inheritance, all these things that we want to do in a good design. So that you get on this level, this takes more time. And if you're there, then you can do something about the modularity. You can do the 4 steps that I showed to you just then, and the modularity gets better. So this is what we do with a big ball of mud. We do these 3 things, one after the other. For technical layering, we have seen that there are different types of architecture, and we have decided to have 2 paths. So in path 1, we start again with strengthening the domain, and then we do the 4 steps. And in path 3, it's the other way around. And I will show you which kind of architecture needs which path to go. So if your system looks like this, and the point is the large domain model at the bottom. So if your whole system is created on top of one domain model, then you have to go path 1. You have to start with strengthening your domain. The other day I saw a thing like that in Berlin, actually. I will not tell you anything about the domain, because then you will guess it. But they called me and they said, well, Carola, can you come? We have a problem. I mean, you know that story already. And I said, yes. What do you have? Well, we have a web system in Java, okay, with 280 microservices, whoa, in 2 million lines of code, which seems a bit a lot, no? And I said, yes, okay. And what's the problem? Well, if we want to change something in the database, everybody has to come. Everybody? Yeah, from every microservice, someone has to be there. Hula. What is going on here? Well, I will show you the system, how it looked like. This is done with a tool, Sonograph. I'm not a tool seller. I can tell you about many tools, but I love this tool because it shows the cycles. It shows how it all works out. And I'm going to tell you what this is. So what does a tool like that do? It parses the Java source code, you know, or the C# source code or whatever, and puts the structure into its database or its memory and shows you the structure. So you can, in Java, you will see the package tree and then the classes and then how those classes are related with each other, how they are calling each other, depending on each other. And then you go there and you say, okay, which bit is one module in your mind, you know, which bit is one part of the target architecture, and then you put part of the package tree in there, or even classes, you know, you can organize everything how you want in tools like that. And what you see on the left side, these rectangles are the architecture elements that we created with the architects in the tool for this system. So we found something, they told us, there's something that you should call mailing. So we did so, and we put everything in there, what's supposed to be in mailing. Import, export, remove, startup, all names that are not the real ones, you know, because it's, again, a negative story, you know, I'm sorry. So we put all the classes in there, and if you would click on the plus in front of one of these rectangles, it would open and you would see the package tree and the classes that are in there. And because of that, on the right side, you see those arcs, green and red. Those are the relationships. So what you see here is that mailing is using import-export. You see the green arc on the left side, it's going downwards, and then right side upwards. So there is one remove. No. Okay. And, well, we looked at that, all those microservices in this system, and then we came down to, well, I will do it like this. We looked at all those different microservices, and then we saw that they all used the thing called model, a model jar. This is the domain model. And I said, well, I'm sorry, but this was not the idea of domain-driven design and microservices following domain-driven design. The model can't be on its own. It must be, you know, separated. They said. And I said, well, can we just move those classes up to the microservices where they belong? And they said, well, yes, if your tool can do it. And I said, yes, we can just move classes. So we started to move classes from down there upwards. And I think, well, after a while we stopped because it looked like this. You see that all these new arcs have appeared. And all these new arcs come from the domain model. And this is what happens. If you have a huge domain model that everybody is using, this is where you end up. And it's very, very difficult to get that apart. You can see it. So in that case, we have a system where security is okay, infrastructure and bugs. We don't well, we have to start with the design. We can't start at the upper level. So we have to do the same thing that we did with a big ball of mud. I'm not going to repeat everything here. And then we can do the modularity, the 4 steps of domain-driven transformation afterwards. So if you have a domain model like that, you have to do it this way. If you have a system that looks a bit like that, where you have you see some separation between the domain models. I try to do it like this, that you see a square here and maybe some relationships, some calls in between, but not too much. So if you have something like that, then you can do it differently. Then you can start with the modularity. You can start with the 4 steps and you can cut the system into pieces, and afterwards you can work on the design. This is possible because sometimes the people say, well, we want to cut it into pieces before we do the work inside. And I can understand, but if you have this huge domain model, I'm sorry, it's really not possible. You have to have something better. So the last part is if we already have a domain-driven module architecture. So if the system is already modular from a domain perspective, then we can just do the 4 steps to find the little mistakes, rearrange a bit, and we are on the good side of the story. So now you know the 4 steps of domain-driven transformation and how they relate to different architectures. And now I come to the domain patterns. I will present the 3 domain patterns to you that we saw. And I will tell you what we were doing with them. And I hope you can relate to that and tell me something, what you see. We gave them some names. Maybe they are not the best ones. But the first one looks like this. We call it a pipeline domain. The second one we call a blackboard domain. And the third one we call a dialogue domain. And I will show you now what this means to us and some examples so that you can relate to that. In a pipeline domain, you have 1 role per step. When you think about a logistic chain, you know that. You know, one person is creating the packaging and the other one is transporting the thing. So there's 1 role per step, one-to-one relation between roles and work objects in some status. So we saw that with the leasing example before, no? There was the salesperson who did the discussion with the customer, and the other one, he voted the contract. One status per object and 1 role. Clear chronological order for the steps, so you can always say where you are in the process. Clear transition between the steps. Here, go on. No? The work result is handed always over to the next role. And, well, in most conference speeches, you will have examples like this, because this is easy to cut. This is easy to transform. The work result of 1 step is the basics for the next step. And I will give you some examples for the pipeline domain. I already mentioned logistic processes. If you purchase on Amazon or some other platform, this is the same. There are clear steps, results, you know, it works like that. Trading on trading platforms. In insurances and banks, it's the same. You know, if you open an account, there are clear steps that follow each of them. You have often in administration processes with regulations, there is as well a very clear step-by-step, one person after the other is doing something. And cutting these domains is easy, like this. It's not difficult. The opposite of that is something that we called blackboard domains, because everybody is working different roles. They work together on 1 or more objects, and there is no relationship, 1 person or 1 role, 1 working object. They're all working on everything at the same time. No handover, no clear order of the steps. I give you some examples so that you can relate to that. The first time that I have seen that was a system that calculated cars or machines or technical facilities. So this was a planning tool. It supported some users, different users, that worked together to create the plan for a facility that you want to build later on. And everybody was calling some people, talking to some people who could build it, to engineers, to salesperson of some company who delivered stuff. And everybody was putting in data and mixing everything up, and someone got a notification that someone else changed here something. So it was a big mass of people working all together on something. If you have ever been in a control center, you have seen that. The observation and monitoring in control centers is a bit like that as well. You don't have steps. You're sitting in front of that thing, and if something goes wrong, you have to do something. This is how it works. Oh, yes. Oh. We have a big client in Berlin who is organizing once a year in February a huge film festival. People from Berlin know what I'm talking about. And I didn't imagine how this works, you know. I mean, really, they have plans of the auditorium where the people will sit, and they change all the time. Everybody is putting some famous people, Scorsese or whoever is there, you know, on some place, and then someone else to sit next to him, and then his security guard must be. It's a nightmare how they work together to create the final plan, and they change it 2 hours before the event. You know, it's really amazing how they do it, and there are no steps. It's really like a blackboard. Actually, programming in agile teams is a bit like that too. You have one code base, and you share it, don't you? And everybody can touch it. And a lot of computer games are like that. And actually, we don't have an idea what to do with that. This is really a horrible kind of domain. To cut this into pieces. And if you have an idea, I would love it, you know, because we have tried a lot of things, and by trying these different things, we found something that we called a dialogue domain. And how does that work? Well, you have different roles that work together on one or more objects, and there is no direct relationship between roles and objects. That's true, work objects, and there's no handover of work results. But there is a negotiation of a plan between the people. They negotiate, they discuss. This is why we called it a dialogue domain. And we mostly have seen that in domains where you have multiple parties from different companies. You know, if they have a software. I can show you an example later on. Where do we see that? We have seen that we are creating a software, well, it's working already for the Rhine River, you know, for the different little harbors to organize how ships are getting in and out, and who is unloading what cartridge where and everything. And they are negotiating through the system. Then we have seen that with dispatchers and customers, where you have to organize maintenance cycles and all that stuff. Oh yes, and this is an example from Hamburg. We have created a software where the people negotiate from different companies when work will be done on the roads in Hamburg. Berlin has not yet bought our system. This is why. Okay, no, I'm just joking. Well, in Hamburg, we don't have so many roads that are opened again and again, you know? No. Open it for one thing, then close it again, 2 weeks later, open it again. No, we don't do that anymore. But yeah, you should talk to someone here. But some games as well fall into this category. And these domains, if they are a bit like that, you can cut them by dialogue steps, you know, by common steps that arrive again and again. You can cut them like that. And in the end, of course, in domains, there are subdomains, and in subdomains, there are subdomains. So what I was talking about was, I just talked about one level, but of course we have different levels. And if the uppermost domain is a pipeline, you can find in some subdomains different versions of all these patterns. And maybe in the blackboard there is, again, a pipeline inside. So you never know how you will end up. And the interesting thing, from my point of view, is that domains change. You know, they change their pattern. And I will show you this last thing with this software to organize construction work that we programmed for Hamburg. You see the touch table, you see on the wall parts of the system, but I'm not going to explain to you how this works because it's really complicated how they work together. But what they do is they stand all together around the table and they discuss the construction work that they want to do, you know. And what we have seen is in the beginning, well, before our software, they were meeting in a room, each of them with an Excel sheet. They were putting Google Map on the wall, and they were trying to discuss time and location, you know. And after 2 or 3 different discussions, they lost where they were. So what we created then was a software where everybody would put its data in. And the telecom could see when the water pipes should be constructed in a road or redone or whatever, you know, refactored, maybe, if in our terms. Or the administration could see, well, we have to redo the cover of the street, but maybe if we do it 3 weeks later, because then the telecom wants to do something, we can put this together, this work. And by putting the data from all those sides, and it was a big step of trust, of course, no? Different companies trusting each other to put their data inside one system. They were all looking at the data and discussing it, and they were happy. But because they could do much more than before, they could see much more than before. But it was really, it was a blackboard domain, as you can see here. And after 2 years of working with all that, they said, oh yeah, no, now we have to start to have some kind of process. And the domain moved towards a dialogue domain. Now they are negotiating step by step, you know? And the funny thing is, this development of the domain was only possible because they had the system. Before, they were not able to have a process. Now they are able to have a process, but the software doesn't have the process. So before, the software was in front of them, you know, moving their domain knowledge and how they worked ahead. And now they are somewhere else, and the software is too late, you know. This is what happens very often from my point of view. So this was the possibility to give them a good work. And now that we have to change the software. So I think this is an agile process as well, where the software is changing the understanding of the domain. And I don't know if they will end up with a pipeline domain. You know, I don't know if they can get there. We will see. Okay, so I hope I showed you the 4 steps. I showed you what kind of direction we go from the modularity maturity index, and I showed you different domain patterns. And if you want to learn more about it, outside there is our booth, as you might see, and there are our books. I've just put them here. My book about sustainable software architecture, where I talk about structures and everything, the book of Stefan and Henning about domain storytelling, and our book, Domain-Driven Transformation, which is unfortunately still just available in German, but we are working on it together with Vaughan to get it done in English. It will take some time. Thank you, and I'm open for your questions.